Hi, and welcome to the Kubernetes podcast from Google. I'm your host, Abdel Sigiwar.
And I'm Caslin Fields.
It's a pretty light news week, but this episode is very long, so buckle in and make sure to stay until the end to hear us banter about all sorts of random stuff.
Welcome to the fourth and last episode of our four-part special series for the Kubernetes 10-year anniversary. We dedicated this episode to AI/ML and spoke to three contributors who are leading work in that area: Clayton Coleman, Chen, and Maciej Szulik. Even if you're not particularly interested in AI workloads, we talked quite a bit about infrastructure considerations for these workloads that are applicable in a variety of circumstances. So make sure you check it out. But first, let's get to the news.
Code freeze for Kubernetes 1.31 release is on July 9th, 2024. If you are a Kubernetes contributor writing code for an enhancement going into 1.31, make sure you get your code done by that deadline.
And that's the news.
Hello and welcome to a new episode in our 10 years anniversary special. Today we're talking to Maciej Szulik. Maciej is currently a Kubernetes Steering Committee. He is also leading special interest groups responsible for kubectl, workloads, and batch controllers. Maciej have been contributing to Kubernetes since its early days, jumping from one era to another where help was needed. He authored the first version of audit and helped shape its current one, and as well as touched multiple other places in apimachinery. He was also responsible for designing and implementing Job and CronJob controllers. In kubectl, he was responsible for the plugin mechanisms and several major refactoring to simplify the code. Since 2024, he joined the ranks of Production Readiness Review or PRR approvers, which we're going to talk about, helping ensure high quality standards for the future of every Kubernetes release. Welcome to the show, Maciej.
I'm glad to be on this podcast.
How am I doing with pronouncing your name?
Very well, very well.
Awesome. Good. All right, so this is the last episode in our 10 years anniversary special. And of course, we couldn't do a 10 years anniversary special without dedicating an episode to HPC and AI and ML, because that's all the rage these days, right?
Correct. AI is the new hype these days. Definitely a lot of movement, a lot of places. In our end, yes, we've actually started a little bit, very shy. I actually looked it up before this call. The batch working group was initiated 2 years ago. I can't believe it's been already 2 years. So a lot has happened. I will admit that I'm very grateful to the group, the entire batch working group, for the improvements that have been done over the past 2 years.
Nice.
A lot of the stuff that the folks that are part of the group has pushed forward in especially the batch API. So we're talking about job primarily and CronJob controllers as well. A lot has been pushed. A lot of those topics actually go all the way back to the early days of Kubernetes when, as you mentioned, when myself and Eric Toon, when we were writing the first versions of job controller, we were already aware of some of the limitations, but because nobody had the time to actually push those features forward and improve the capabilities of the job controller, a lot of those features, or in a lot of those cases, limitations actually, were lingering for quite some time by now. And primarily, I would call out Aldo and Michał for doing amazing job to push those unsolved problems forward. I will admit that it wasn't easy. There was a lot of bumps on the road, but in the end, we've made it successful, and a lot of the users today are not probably even aware about those early limitations, and I'm happy to talk about them a little bit later.
I would like to talk about what those limitations are, because it's interesting that the group started 2 years before the AI hype was even a thing. Right.
Right. I mean, if you look back, the HPC, and there's a lot of folks that are part of the batch working group, a lot of people that are in the university area, they have been doing HPC and some sort of MA, AI, ML workload type for a decade or even longer.
Yeah.
So it's not like a big thing. It just so happened that over the past, 12 months, a little bit less, it actually hit the highlights and the current news. But it was actually a thing that was in the development for quite a while. And I will admit, when I was back that could have been even probably 10 years ago, when I was part of the PyCon program committee. I remember when Python initially started shaping from the web development, a lot of those Django frameworks, Flask, and all those topics, and slowly migrated the majority of the topics that were showing up for program committee to review. A lot of those topics were slowly shaping up around the HPC, machine learning, and all those topics. So it's not a brand new topic, but it was just lingering there and behind.
Yeah.
There are some areas that usually take a little bit longer to catch up. And like I said, the limitations of Kube that we initially had, for example, the job primarily, where the biggest hurdle that was with the job controller was that for the job to be able to to execute, it had to keep the actual pods running, the code around in the cluster for as long as the job itself was running. So that was fine if you had a job with 100, maybe less than so pods running. But if you're running at a major machine learning frameworks where you're running thousands or even more than that of pods in a job, and you have those thousands of pods lingering around until the job finishes, which can take even days or weeks, you're wasting a lot of the resources in the Kubernetes cluster. So
I see.
And when we initially wrote the job controllers, we were aware of that problem. But because that was the first installment, the first version, we were like, okay, we're going to accept that kind of limitation. We want to give something away to the users to put into their hands so that they can test and verify what's working, what not, what kind of feedback we would receive, and based on the feedback, address them. So the rewrite that Aldo was doing over the past 2 years, well, we actually finished that roughly a year ago, was that he changed how the job controller is calculating the finished pods and keeping that information as the pod is finishing and properly updating those counters so that we don't have to keep those pods lingering around. So previously, if you had a job of 100 pods, you would have to keep the 100 pods
running
until the job finishes.
Yes.
Now, every time a pod finishes in a job, it gets properly accounted for, and it can be removed from the cluster, releasing the resources.
Got it.
So a lot of those small improvements, very often in the back, but not always, because there has been a lot of work around allowing people to retry or primarily say whether a particular problem in a job is retriable, whether it should be retried. There was also the expansion of the job API, and that was also one of, if you look back in the Kubernetes issues, that was one of the very first issues shortly after we created the job controller, the index job, which basically allows you to assign a specific index to every pod. We were aware that that kind of functionality will be useful to the job users, but again, we didn't have the capacity to push that kind of functionality forward. So that's where the batch working group again helped. They step up and implemented that kind of functionality. So currently, there's a lot of users of the index jobs. We're actually evolving the index job. In 131, there's something that is called elastic index jobs, which allows you to define that only certain indexes within a job can be finished or not. So there has been a lot of changes like that over the past, I would even say maybe more than 2 years. The official working group started about early 2022. I remember we were presenting for the batch working group already in the KubeCon Europe in 2022. And if I remember correctly, that was in Valencia.
Valencia, yes, 2022.
Yeah. So we were already asking around whether we can present the working group even before it actually was officially accepted by the steering committee back then. But yeah, the work has been going on for even a little bit longer. And I will admit that the Job API, the Job and CronJob API, which, a fun fact, I'm not sure how many users are aware, CronJobs, when we initially wrote it, it was called Schedule a Job.
Okay.
Eventually, over the next 2 or 3 releases, we figure out that the Schedule a Jobs might be a little bit confusing to a lot of the users because of the kube scheduler, which is responsible for placing the pods on your Kubernetes cluster. And we wanted to bring it more similar to the Unix world, where a lot of people is familiar with the cron daemon, responsible for scheduling. Scheduling is again the wrong word, but
running processes,
ensuring that a particular task at a specified point in time, or repeating those executions. So that's when we decided to rename the scheduler jobs to CronJob, which was on its own a very interesting and very involving task, because a lot of users by then started actually using heavily the scheduler job, and we wanted to make sure that the transition is pretty smooth. So we were actually allowing them to use both names at the same time. There's a lot of API machinery, and that was the time when I spent a lot of the time with the API machinery with Clayton, adding and expanding the API machinery to be able to support both the cron job as a resource name and the scheduler jobs.
Okay.
So we had the capability, and that capability exists until today, even in the kube code. We had the capability to read both the cron jobs and scheduler jobs. But in response, we would always return to the user information about the cron job to slowly force using the users through that transition.
Got it.
But I will admit that was interesting time.
I have a question for you, and this was not even planned on the doc, but I just thought about it. Particularly for cron jobs on Kubernetes, the example you gave earlier, if you're running a job that will end up running 1,000 or 2,000 pods, isn't the churn rate a limiting factor in Kubernetes itself by how fast those pods can get spun up? Or that's not a problem?
Well, you as the job author have the ability to decide how big parallelism you can allow for your particular execution. So I'm not sure how much familiar you are with the Job API, but basically Job API has 2 main configuration options. The first one is how many pods you want to run of your particular action that you want to execute. And the other one allows you to define how many are executed at any point in time. That's called the parallelism. So you can define that, my job is 100 pod action or a task. But for whatever reason, I don't know, you know that at this point in time, you can have only at most 5, whether that will be your quota limitation or that will be your resources usage. You know that at this point in time, you can only allow it 5, and there will always be 5 running and no more.
Got it.
Plus minus some skew when we are closing a previous one and starting a new one. But for example, if you're running some kind of backup task or some heavy computation overnight or over weekend, when you know the resource usage will be very small in the cluster, you can go a little bit crazy and bump that limit to 20 or maybe even 50 pods running in parallel.
Got it.
So I would say that's the limitation. And even if you decide to go full on board with completions 100 and parallelism at 100, when we are actually creating the pods for you, we're not creating all of them at once. We're actually batching the creation of the pods to ensure we're not overwhelming the API server with those creations.
Got it. So that was actually going to be my follow-up question. So there is some logic in the controller to make sure that pods are created at a specific rate, if you want. Or
it's not like there is a specific rate, but we're just ensuring that we're slowly adding more.
Got it.
And if we're seeing that there is a problem with creating those pods, we'll actually back off and slow down the creations or stop it for a little bit longer.
Got it.
So it's not immediate running full on board. It's slowly getting to speed to whatever is allowed in the cluster.
Got it.
Because obviously you can run into stuff like quota, resources, or anything can happen in a live cluster.
Got it. All right, so then I'll pause here and go back to talk a little bit about you. What's your experience with all of this? What's your background? And how did you ended up working on these like HPC/batch kind of workloads on Kubernetes?
Since the early days, I was involved in the controllers. Like I mentioned, the Job, CronJob controllers, that was one of the first major tasks. It's funny because for the Kubernetes 10th anniversary, I was looking at my contributor card, and I also remember that someone mentioned that to me, that my actual first PR, pull request to the Kubernetes code, was actually bumping or updating to newer version of Cobra. Cobra is the library that we use for writing kubectl.
Yes.
So all the nice things with regards to how we parse flags, arguments, that is provided by the Cobra library. Mm-hmm. And then slowly from that, I transitioned to writing the Job and CronJob controller. And that was because in my previous jobs, I was writing something very similar. Mm-hmm. The only difference that back then it was behind the curtain. I could not share anything what I was doing or anything like that. So when I had the opportunity to work on the Job and CronJob, I just jumped the ship and slowly started working on it. Initially, the goal was to just write something, like I mentioned, schedule jobs. We didn't even thought about dividing that into those two controllers. We started with, we want to have the ability to run backups or basically some kind of periodic tasks. Mm-hmm. And then while we started talking with Brian Grant, Eric Toon, a couple of other folks, Dario, we realized that we actually want to do first the Job API and then build the scheduler jobs or cron jobs later on top of the Job API, because the Job API will actually, first of all, we look at what the Borg already had on the Google side. Mm-hmm. And if you look in the paper, there are clearly two primary types of workload. There is the continuous workload, so think deployment replica set, mm-hmm. and there's run to completion. So basically, in our case, that's a job type of workload. That's how we started working with that. That's how my first love, I would say, to Kubernetes. That's why the batch API, because both Job and CronJob controllers and the APIs are so dear to my heart. And that's how I've always kept a very close eye to what's going on in both of the controllers. Even though by now, both the Job controller has been rewritten by Michał, Aldo, and a couple of others so much that it does not resemble what I wrote originally. Yeah. The CronJob controller was rewritten from scratch by Ally, because for a very long time, CronJob controller was written using the initial primitives, using the mechanism. So basically, instead of listening to what kind of changes are happening in the cluster, mm-hmm. and reacting to the changes, the first version of the cron job was iterating over all cron jobs in the cluster every 5 minutes or so, and then reacting to those changes, eventually triggering the creation of a job from that cron job. Yeah. Which was very limiting. Again, the similar problem as with the job, it had very significant impact on performance. And we knew for a very long time that we need to rewrite the cron job controller to use the shared informers and the mechanism where we are listening to changes that are happening to the cron job resource and reacting, and to the job resource and reacting to them constantly. When we did that, Ally did the majority of the rewrites a couple years back, like 3 years. I remember he was presenting this topic during one of the NA North America KubeCons, mm-hmm. and that was still the virtual one. The performance gains were pretty significant, so I will probably encourage everyone who are interested in that history to try to look up my name and KubeCon NA presentations where that was being discussed.
Well, we'll find it and add it to the show notes for the
that
episode.
Would be perfect.
Yeah, we'll do that.
So that naturally, and then I eventually, over the years, I got involved and become one of the SIGAPs, so that's the special interest group that is responsible for all the workload and the batch controllers. I became the chair and the lead, and that has been for 3, 4, 5 years by now, I guess. I can't remember. Probably something that we could look up if someone is interested in. And when Aldo and Abdullah pinged me about the ability to create the batch working group, I was, oh yeah, that's definitely something, because I know that there are limitations in the batch API. I can name you at least 2 or 3 that I would like to see being resolved, but I just don't have the time myself, the capacity to be able to work on it. But I can provide or guide people. There are even presentations from back in, I think I did a presentation back in Copenhagen. So that's 2018, KubeCon Europe. I did a presentation about writing controllers. And during that presentation, I asked people like, who's interested in rewriting the CronJob controller to the new pattern using the shared informers and so forth. I think it took me another year or 2 years to actually find the volunteer and work with him and be able to push this idea forward. I will admit that I'm planning to do a refresh of that talk, because until now, there are 2 presentations that I did that I'm still seeing that a lot of people is looking after them, and I've used them multiple times as a reference. One was how to write kubectl code, so basically a 6 CLI tour, because like you mentioned, there has been a major refactors in kubectl. We try to rewrite kubectl such that it has a specific form. There are initiation where we create the command, then we do validation of all the parameters that the user provides, and eventually we actually invoke the command. The idea is to be able to first build commands on top of one another. For example, wait is one of my perfect examples where we are actually using the wait code implementation in delete command, where we're waiting for the finish of the deletion. And I did a presentation how to write and look through the kubectl code, and that was one. And the other one was how to write Kubernetes controllers. And I'm actually planning a refresh of the latter later this year in KubeCon North America.
Nice.
Fingers crossed so that my proposal gets accepted. But this time around, I'm planning to play around with the idea, because currently there are multiple tools that you can use to write a Kubernetes controllers. That's not only the built-in shared informers and client Go, but there's also controller runtime, there's kubebuilder, there's operator framework, all the other tools. And I think it's important to remind people and for those people to have those references, because as you're probably aware, more and more newcomers, even though we're 10 years in this game, there's more and more people, especially newcomers, that are coming to Kube and are struggling. Because for us that we've been with the project for 10 years, a lot of those topics are coming naturally. And I am catching myself very frequently that for me, a lot of those discussions topics just come naturally, and I know where to look for it. Even though I'm not 100% sure I can find the right piece of code, but because I know what I'm looking for, even though the particular piece of code moved, but because I know what I'm more or less looking for, I can quickly navigate the code and find that place.
Got it.
For example, what I mentioned, cohabitating resources, which is what allowed us to have CronJob and scheduler jobs. I could easily find it where, if I'd be interested in API machinery and how to do it. But for a lot of the people, the Kubernetes code today is very intimidating because it's a lot of work that has been put over the past 10 years by so many amazing people that put sweat and tears into making this project where it is today.
Nice. So then I'll bring us back to the original topic of the conversation, which is AI and ML. And since you've been involved in quite a lot and for a very long time, I think you'll be the perfect person to help us and the audience make sense of all the terms. So HPC, AI, ML, and batch. What did these 4 words mean, actually?
Okay, so let's start with the simplest one, AI, ML, because that's probably on people's minds these days a lot. So AI is artificial intelligence and machine learning. And for a lot of the people, that's probably a synonym. And
Yes.
actually that is, because AI these days is nothing more than much better machine learning from a couple years
Yes.
ago. The batch is pretty broad topic because it comes from the ability to put several resources and try to either place them on the cluster at once within a single unit of invocation, or somehow from the Unix environment where people are talking about batching is usually packing them together and somehow execute in the single unit. And lastly, HPC, I will admit that that has been popping up and back and forth, and I have some time hard to figure out what it means but basically it's about high performance computing. So if you again go back to machine learning, the idea of machine learning is to put our computers to use like 100% and just analyze what kind of data you have. And APC is just that. It's actually using the full power and the full performance of your computer to be able to, whether you're looking at the images and try to find similarities between the images, or whether you're looking at text generation, you're trying to digest all that information into a binary representation that you can then just use for whether that'll be predicting what kind of output a user requests, or kind of whether that'll be the output will be text and image, or more sophisticated like video or audio.
Yeah. And also we have to say that, just to add to that HPC have been around for a very long time in our field, in the tech industry. It's just
That's
that
correct.
it's probably today means something broader than before, when it used to mean very, very expensive, very proprietary hardware, essentially.
Yeah, correct. I mean, that's one of the gains that we have with the Kubernetes. And that is also one of the topics that has been popping up frequently during the batch working group meetings. We've been lucky to have some folks from the university areas. So those are the folks that actually have been doing HPC for multiple decades, I would even say, before AI started to become
A thing.
famous, famous, and like the hype. They've been doing that for a very long time. And they actually did a lot of the tooling, but in most cases, the tooling was very highly dedicated to the environment that they had. And what we're currently trying to do is we're trying to combine their dedicated pieces of software with the genericness, let's call it that way, of the Kubernetes and the ability to run any kind of workloads on the Kubernetes. And there's also the recent 2 additions to the Kubernetes. So we've created 2 brand new working groups this past month, 2 months ago. One is devoted to ensuring that the serving workload. So once you have the model built,
Yeah, the inference part.
exactly, you want to make sure that the serving part is also working properly. And there are multiple approaches to how to do it best. So that's one thing. But the other side of that equation is how to actually use the graphical processing units, so GPUs,
Yes.
to actually perform that. It's not only for the batch, because there's a different pattern, there's a different usage pattern for batch and for the serving workloads. So there's a separate group that is specifically focusing on allowing users to efficiently use the GPUs, because a lot of the primitives that we currently have in the Kubernetes, they were only focusing on CPU and memory and a couple other primitives like quota and whatnot. But we didn't originally wrote cubes such that it will support GPUs.
Yeah.
Especially that they are used a little bit differently than CPUs are. So the working group is currently working on making sure that enabling and the dynamic resource allocation, that's the whole enhancement that we're building around,
Yes.
is possible in the Kubernetes cluster, and that people can both allow their users and for the users to come and actually efficiently use those resources.
Nice. Yeah, that's actually pretty interesting. That was going to be my next question on how all of this is impacting Kubernetes. And I was not aware that there was two new work. I was aware of the inference one, the serving one, the new working group, but I was not aware of the
device management.
Yeah, for GPUs.
Yes.
I mean, for GPUs, I think so far Kubernetes, one of the few things you could do is basically influence the scheduling decision by asking the scheduler to put your pod on a node that has a GPU, right?
Yes, but that's very high level because I'm not an expert in that area. I will say that there are people that are so much more smarter than I am in the GPU, in the device area. But basically, GPUs are allowed to be divided into various pieces, and you can use either a fraction of a GPU or
like multi-slicing. Yeah, you can slice a GPU.
Exactly. You can slice a GPU to whatever. Theoretically, you can think about it, oh, well, I'll just figure out that my GPU will be divided into 10 equal pieces. But actually, there will be people who will want to divide it into 16 or 32 pieces. Yes. There will be people who will be using more, and there will be people who will be using less. And the ability to modify that usage, and by that, there's a little bit of dynamicity needed to be able to pick and choose what you want. Whereas with CPUs, we can only say, oh yeah, I have 10 millicores and you have to divide it statically.
Yes.
Whereas with GPUs, the dynamic side is much more important. And that's the big thing that the device working group is doing currently. And they're building on the DRA, which if you look at it, DRA or dynamic resource allocation, the topic has been in the works for over a year now, but it was slowly moving, and it just so happens that the current hype pushed a lot more power and a lot more people towards that area to be able to push and focus Kubernetes into proper usage of those resources.
Nice. Well, I think we should probably add this to our list of topics to explore, because those two new working groups sound interesting. So before I go to the question that we, of course, ask every guest, what do you see for the future of Kubernetes? But before we go there, can you explain to us what PRR is? Because I think we have never discussed this in the show.
Yeah, so Kubernetes is trying to, first, we've been around for 10 years and want to make sure that the people who are using the Kubernetes project have always the best experience. So we need to make sure that the stability is there, the functionality is there. What kind of new feature, especially the new features, you're trying to advise that it fulfills the requirements for both the cluster administrator to be aware of what's going on in the cluster. So you can think about the monitoring, but also for the users and how to divide the responsibilities, but also how to monitor if I'm rolling out a new change, what kind of signals that I should be looking for that the new functionality is not working correctly, how to turn on or off this new functionality, what is the upgrade path, are there any requirements with regards to system level components, whether you need to have something to be able to use a particular functionality or not. So production readiness review is actually a part of every enhancement document. So Kubernetes enhancement document, KEPS for short, is a document that describes your new feature, your new functionality. And as part of that document, there's a section towards the end of this document which goes through all those questions where you're thinking about what kind of additional storage requirements will be. If you're adding new fields, what is the maximal potential size that the new field will come into the existing APIs? Whether you're creating a new API, what is the size of the new API? What kind of monitoring requirements you have. So you can call out specific metrics. What is the acceptable SLI for those metrics? So what is the level at which point you should start to be worried that your functionality is not working correctly, whether you should start thinking about rolling back or you can actually work on it, or maybe at which point you should decide to actually turn off and report a particular problem with the functionality. And we're helping the authors of every enhancement to ensure that the production readiness, so that your future, it will be working in a full-fledged clusters. And because oftentimes there will be people who are thinking about, I want to add this particular functionality only. And it's a simple thing. But if you start thinking about and looking at the interaction that this particular feature will have at different components of the cluster, it suddenly looks not as simple. So that additional set of eyes that is looking at it from a different angle is a critical piece to ensure that we are maintaining the high standards for future Kubernetes releases.
Nice. Thank you. That's a really good explanation. So my last question is, where do you see the future of Kubernetes?
I think the biggest challenge that we're currently seeing is to ensure that the community has the potential for further growth. The biggest problem that I've noticed myself over the past 2 or 3 years is that there's, with the majority of the layoffs happening in the IT sector, we've lost several contributors to the project, whether that's to the main Kubernetes or a lot of the projects that are built around the Kubernetes project. So I would say that's the biggest risk, and that's the biggest investment that the project has to continue to make, because on one hand, we need to make sure that the experience for new people coming to help to work on Kubernetes is simple and it's picking up any kind of task. Like, for example, going through enhancement process is achievable and it's not overwhelming. Either that's through mentoring or helping people understand how the process works.
Nice.
But also to ensure that the ease of use is there, because that has been mentioned several times in the past that there are so many options that we currently have in the Kubernetes, which I believe is probably a problem of any medium-sized to high-size project, that the entry line for every user is so hard.
Yeah.
So probably that will be the focus, the ease of use, the friendliness for both the users. And by users, I mean both the actual consumers of the platform and the cluster administrators, but also for the developers to be able to sometimes fix a simple thing rather than just comment and
Yeah.
Nice.
All right. Well, thank you very much. Before we leave, we just have to acknowledge the fact that your audio quality is good because of your son who gave you a gaming headset, right?
Correct. Yes, my oldest son. I did reach out to him. I needed a proper cable mic, and he was like, "Oh yeah, I have a very good gaming headset." And he was like, "You can definitely use that one." Like, thank you.
Awesome. I didn't want to leave before we acknowledge that. All right. Thank you very much, Maciej. Thanks for your time.
Thank you.
Hello, I am excited today to be talking with Clayton Coleman. Clayton is a longtime Kubernetes contributor, having helped launch Kubernetes as open source, being on the Bootstrap Steering Committee, and working across a number of SIGs to make Kubernetes a reliable and powerful foundation for workloads. At Red Hat, he led OpenShift's pivot into Kubernetes and its growth across on-premise, edge, and into cloud. At Google, he's now focused on enabling the next generation of key workloads, especially AIML in Kubernetes and on GKE. Welcome to the show, Clayton.
Thank you, Kaslin. It's a pleasure to be here.
And this, for everyone's awareness, is the episode so nice we're doing it twice, because we actually recorded this interview once and then had technical difficulties. So I didn't know that you were also a tester. Is testing one of your passions?
Actually, when I graduated from college in the winter of 2001, and it was at the depths of the dot-com crash, and there was no one hiring, except I went to work for IBM, actually, out of college as a tester. And I was such an annoying tester because I would not only find issues, but also file bugs at the same time. They were like, we really need to get this guy out of test. He's super annoying. We'll just make him fix the bugs that he introduces. So I became a developer.
And still today, good at finding those issues. Perhaps we do need to file an issue with our recording software. But thank you so much for being on again and for testing that. Testing is one of my personal passions, so I certainly appreciate that. And I also started out in QA, so we have that in common, which I didn't know last time. So we learned something new from this re-recording already. But today we are here to talk about AI/ML and HPC on Kubernetes. And you've been here since the very beginnings of Kubernetes, before 1.0, when it was mostly Google and Red Hat kind of working together to get it going. So could you tell me a little bit about your early days with Kubernetes?
I started at IBM. A lot of us left IBM about that time to go work at this really small, mid-size, well, not that small, maybe 4,000 people, but a small open source company that was also in the Raleigh area called Red Hat. And I was working on OpenShift. It was platform as a service. That was when Heroku and Engine Yard and .cloud were all trying to make it. So OpenShift was open source platform as a service with this really cool idea, containers. And one of the things that we really noted was there were two problems. One, which was nobody wants simple things. Red Hat's been working with enterprises for a really long time, with Red Hat Enterprise Linux, and you're supporting production workloads. With alongside the growth of cloud, Linux became huge. And the reality is that everybody says that they want simple, but once they get past the point where they need simple, they then need complex. And everybody's complex was different. So we were seeing PaaS was too simple, and we got kind of a call out of the blue at Red Hat from some folks at Google working on this weird project called 7 of 9, which was their code name for it. And it was, they wanted to do something with containers and Docker and kind of listen. And we're like, oh, that's interesting. And then we didn't hear anything from Google for a while. They're like, well, we don't know if we're going to open source it. And then about 6 months later, right about this time of year, just a little bit before the DockerCon where Kubernetes was announced, we got a call, hey, are you still in? And we did that last minute. Well, if we're going to go big with containers, it's going to be a lot bigger than PaaS. So this seems like the right opportunity. And so I've been contributing to Kubernetes ever since then. And, it's great having a 10-year celebration because it's been a pretty crazy journey. We've all, how do I say this, jointly recognized that even though people say they want simple things, they really just want to get what they need to get done, which is often quite complex. And then they want it to just keep working. And so a lot of the last 10 years, saying like, Kubernetes is neither simple, nor does it try to be too complex. And that's a really hard place to be in the middle of because everybody comes to it with a different set of assumptions. And so that is the most interesting and difficult part, which is something that everybody hates because they have to use it because it's so widely supported. It does so much of what they need. It's been an interesting 10 years, and I couldn't imagine doing it any other way.
That is true. Enterprise kind of has this entropy to it, doesn't it?
Absolutely.
Nothing stays simple for long in enterprise.
And it's actually, this has been I think a group of us have always kind of chatted about this. Everybody needs a platform. I think Kelsey had a great quote about this, is everybody needs a platform, but it's really important that people build their own platform. And part of the reason for that is everybody's requirements are just a little different. You need a different set of tools. Your teams have different set of experiences. You're building different workloads. And so you can't get 100% agreement on the right way to do canary rollouts or the right way to run microservice workloads. And the best you can do is offer something that most people will choose over building it themselves. And I think that's actually a worse is better kind of approach. And I think, as we're getting into AI, that's the classic, everybody's so excited about AI, and then you realize that it's just doing, this big statistical average of every human on the internet, which is kind of, if you think about it, you're like, well, humans are in aggregate not all that good at telling you the right answer every time. So as I've been getting into AI, I've really appreciated that worse is better mindset.
Worse is better mindset. That's quite the way to frame it. I think we're all kind of figuring out how to think of AI and what it's good at. That's a question that I'd like to ask that is not on our list, actually. What do you feel like AI is really good at this stage?
I think this is the exciting part about AI is, there's such an enormous amount of hype. It's such a cool and amazing experience because pretty much up till now, you have to translate what you want to the computer. And there have been various chatbots over the years and, Eliza bot, where you say things and it just asks you questions back, which works really well because humans love to talk about themselves. But I think that natural language interface, it's still really early. LLMs as they are now are just the start. But we can actually now imagine user interfaces where you just type things and stuff happens. And it's not perfect. I think there's an interesting tension, which is how good does something need to be reliable? And different use cases actually have different needs. So like a really great example would be if you have the time, you can run a whole bunch of, you can ask the AI a whole bunch of times and you'll eventually converge. That's what a lot of people find value in chatbots is maybe the first answer isn't perfectly correct, but you can keep refining until you get something, you talked it through, it was your rubber ducky. That's a very valuable use case. I've seen super useful translation of different types of programming languages between each other, which is just a time saver. If you see an example and you could go manually do it, but if you can have the chatbot or the code completion, take a chunk and then generate it out, overall you're getting a net improvement. Even simple things like looking at pictures, you can speed up a lot of repetitive actions. And I think that's actually the real superpower of today's AI is it's not that it can give you something precisely, but it can automate doing things that you can do but have better uses of your time. And that's what we've been doing with computers for 60 years is, of course, I could learn long division and linear algebra, or I could write a program and then everybody can benefit from it. I think we're still in that early phase. The surprising thing for me is how many people are finding productive uses for this. There's a little bit of the cynicism creeps in, which is this is overhyped. It's absolutely overhyped, but there are people in production today in very traditional businesses doing very traditional, boring things that are using LLM under the covers, and that's awesome. And I saw that in Kubernetes as well. Early on, probably a lot earlier than people would have expected, your credit cards were running on top of Kubernetes somewhere. Transaction processing was done on Kubernetes. And you don't really see this as a consumer. Sometimes it's scary, but it was always scary. You just didn't know about the details of it, right? You have to hide some of these problems and you have to trust that other people are going to put the due diligence in. And that's how we can helping people run LLM workloads.
I have occasionally talked to some folks who worked on some early days of Kubernetes-ish era, like credit card systems, and that is always terrifying. Maybe we can find someone to have on the show one of these days.
We had to go debug one of those once, and I got to look at, we had to go look at a bug on a system that had been running for a few years on Kubernetes 1.1 code that was running in a production enterprise environment. I was actually surprised. The early version of Kubernetes was pretty simple. We hadn't gone and added all the extra features. And I think that was actually a really strong point of Kubernetes in the early days, which is if you can make something that's simple enough that you can go back and understand it, that does a basic thing well. I actually like to think about that design principle when we think of, if everybody was going to go run inference workloads, right? Like inference is the new web app. I got to say that at KubeCon. Tim quoted me on it. I felt very proud that I've been quoted for something. But I think, it's pretty reasonable that most of our applications in the next few years, at some point in these big web-facing workloads, in enterprises, in personal life, something you do is going to touch an LLM. There's going to be a lot of it. It's very compute intensive. And there's going to be so much of it running. It's actually not that complicated. What we can do is how do we go find those simple things that help most people run inference workloads? And Kubernetes is actually pretty good at that, helping you run lots of workloads and standardizing it. I think there's some real opportunities for Kubernetes to streamline that, make it more reliable, make it more secure. How do you make sure that it's easy for people running lots of workloads to keep those workloads apart? You don't want data for one part making it to the other. That's something Kubernetes can help with.
I do want to dive into that. I know that you're involved with the brand new working group Serving, and we'll dive into what that means in a moment. But first, I want to address terminology. So we've used the words inference, we've used the words serving, high performance computing, HPC, AI, ML is very common. I don't think we've really talked about it, but we have all of these different terms for these workloads. And I feel like they're often used interchangeably. Do you think that they can really be used interchangeably? How do we use these terms in the community and kind of what do they mean to you?
I will say that over the last year, I've struggled with figuring out there's a lot of new terminology emerging and there's some old terminology we're trying to map. So terminology is a hard problem and it's very important. So I will say, from my perspective, one of the things that Kubernetes started with was helping make stateless web applications work well. And that was a need people had. They had it wasn't just the one Java monolith that everybody contributed to. In 2012, 2013, we had 50 different programming languages, 150 different language frameworks, and Rails was big, and all these new Java frameworks like, oh, no, don't forget about Java. We're still cool. And we're really fast. You just have to learn Java to use us. All of those workloads we're trying to run together. So the early days of Kubernetes, those stateless web applications, the term I think that I can't say with authority is that what we should all use for all this, but we tended to use the word serving to describe a workload that expected to run for a very long time indefinitely and to take traffic. And conversely, the dual of serving is batch, where you say what I want and the computer at some point in the future will respond and give you back an answer or move a bunch of data someplace and tell you that it succeeded. And so kind of Kubernetes definitely focused on serving. And actually, I think Kubernetes is a really great system for serving. It doesn't solve all the problems, obviously, but more than any other system in the world, Kubernetes runs serving workloads. I think maybe the most number of serving workloads run on Kubernetes, but I couldn't prove it to you. And batch was important, but it wasn't the most important problem people had. So we knew that there would be batch. So we wanted Kubernetes to support both serving and batch. In the last few years, batch has become very important. There's a lot of mature batch systems, especially in the high performance computing area. There's very popular things like Slurm that are kind of orthogonal to Kubernetes. And then you see a bunch of people who are doing a lot of serving suddenly have all these big data workloads alongside their web apps. Well, the natural thing is to add those to Kubernetes. So batch has gotten better on Kubernetes, but it's by far not the only way that you can run batch. And now with AI/ML, we kind of have like two big workloads. We have training, which is your development process where you go do a bunch of complex computation. And you have inference, where you take the model and you ask it a question. And even inference can actually be both batch and serving. So traditionally, inference was a lot of batch. Like you'd make a model, and then you'd gather up all your day's data, or look at your data lake and build a big thing, and you'd send it off as a job and get back some data that you'd put in a database somewhere. The big change with LLM is if natural language is a human interaction, then suddenly all of the systems that we've built for humans clicking around, we actually now want to wire those up to LLM. So suddenly, especially with large language models, inference has really become an online thing, a very interactive. And so that requires low latency. And if you need low latency, you might as well just keep the thing running all the time. And so we have inference that is more batch focused, and we have inference that's more serving focused. So sometimes inference and serving get overused. I tend to say like online inference or real-time inference. And then there's, maybe offline inference or fungible or low latency or batch inference. That's kind of like the difference. But like all things, I don't think you get 10 people in a room and get one answer.
Yeah. I wrote a blog post about this recently, which you reviewed. Thank you very much for that.
You're quite welcome.
I am very much of the opinion that I think serving is very subtly different from inference. And like you're saying, that inference also covers some like batch kind of workloads, but training is very much in the world of stateful workloads where it's very resource intensive and very long running. So it tends to be run as batches as well. So I feel like training is kind of its own area of use cases, but inference kind of covers a couple of different ones. So I like that.
As an industry, we've never come up with an official name for the stuff that services are made at. Sometimes you say services, but what does service mean? We talk about web apps, but web apps, are an older term. There's API front ends, but sometimes you can have API backends. So I think I've certainly struggled as we're trying to clearly communicate what we are and what we aren't in these new working groups that we are putting together. Terminology really matters.
And speaking of terminology, to dive into those working groups further, let's go over the Kubernetes terminology here for a second. So a SIG, or a special interest group, are the groups that work is kind of split up into in Kubernetes, but they're the highest level of groups. So we have SIGs like SIG networking, SIG K8s infra, SIG API machinery, all of these very high level concepts. And those are special interest groups is what SIG stands for. I don't know if I said that. And then SIGs usually break down their work further into sub-projects. And working groups are kind of this concept to the side of all of that. They are topical groups, I would say. They're spun up when there's something going on that the Kubernetes community thinks that we need to focus on that maybe doesn't fit neatly into a SIG, or it's really important but might not live forever. So the SIGs are things that are going to be important to Kubernetes basically forever. Like networking is always going to be a part of Kubernetes, so we always need to have a group focused on it. But sometimes we have these areas come up where we think we really need to focus on this. We're not sure what it's going to look like in the long term, but let's spin up a group to figure that out. So I think that's kind of where working groups come in. They don't have sub-projects, but they're kind of treated like SIGs in that they have their own meetings. They kind of have their own space within the project, though they're usually kind of related.
Yeah, and a really important distinction is that ownership, a SIG owns code. And so working groups are composed of people maybe from multiple SIGs creating code, but ultimately for the project to kind of have that control over, what is Kubernetes? What are we going to support? What are we going to maintain? The mechanism is SIGs still have to take ownership. So a SIG sponsors, multiple SIGs might sponsor a working group. The working group can definitely generate code, but ultimately somebody at the end of the day is going to need to support that over time. And so the SIG is fulfilling that responsibility. So the working group's job is to kind of help bring together SIG members around key problems, but they don't get a free pass. Somebody still has to pick up the pieces when the working group is done.
That's a very important component I had not thought to explain. So thank you for that. I'm going to use that when I explain working groups from now on. So you are part of the founding group, I suppose, of working group serving. And we also, in the project, have working group batch, which has existed for a bit. We were talking about how Kubernetes has kind of been focused on serving or web server or stateless type workloads for a long time. And one thing that I've noticed when I would talk to folks in the HPC or high performance computing community is Kubernetes has been a strong pick for those types of workloads for a long time. But what I've heard from them is that the scheduler is not as fully featured as they need. So sometimes they end up implementing their own custom schedulers, but still using Kubernetes for some of the infrastructure management underneath. So it makes sense to me that we would spin up a working group batch to address those types of workloads. And on this episode, we're going to talk to the head of working group batch as well. But you are in working group serving. So do you want to talk a little bit about working group serving and working group batch and how the beginnings of working group serving are going?
Absolutely. And Kubernetes, I've been around for a long time. When we were just getting started, we didn't think in terms, we're focused on stateless. We knew we would want to do stateful eventually, and we wanted to make sure there was something to kind of support batch, but it wasn't the biggest focus for the vast majority of people adopting Kubernetes. And so the SIGs were actually set up around what we thought about at the time. And then over the years, we've tried to figure out how we evolved the project. And so working groups, the early working groups, we weren't quite clear on what they were. Now we're starting to really kind of lean into that. One of the most successful working groups, I think, and a model is working group batch. It was a big, ambiguous problem that crossed a lot of domains. The folks involved identified some key points of what Kubernetes should do best at, which is bringing the ecosystem together, providing great foundations so that even if the foundation itself is somewhat arbitrary, some of the benefit of Kubernetes is you just don't have to argue about how to implement this basic stuff. You can go argue about how to implement the higher level stuff. And so the folks in working group batch looked at the problem space. They started a number of things to improve scheduling based on some of that feedback. They looked at things, a big part about batch is the ability to queue. to say, well, I need this to run, but because I've already given it to you and I know it's going to take some time, sometimes I can wait longer. And so that queuing concept was really missing from Kubernetes. And we said, well, we don't want Kubernetes to be this big monolithic thing that keeps shoving everything into the base. We wanted clean layering. And so the queue project was actually created to try to find the common primitives among a number of these above Kubernetes batch orchestration systems so that you could say, hey, I have this job. If somebody else comes along, though, who's more important than me, and they submit their job, when the resources become available, maybe that other person, their job runs first versus my lower priority job. So that idea of a queue and the idea of prioritization was not something that was really appropriate for us to add to the Kubernetes scheduler, which is about pods and workloads. And so that time fungible aspect, the queue project was really successful, and I'm excited to listen to the podcast and hear the batch team talk about it. We use working group batch as a model because batches, if we say Kubernetes was about, there's these two big classes of workloads, those that run forever and those that don't. Well, maybe in the last 10 years, we've actually kind of taken our eye off of, well, what's the next step for web applications, for backends? And AI is a great opportunity because it's novel. You've got these new use cases that need a lot of compute. They're kind of like web applications. Inference is simpler than web apps. There's only a few things. Everybody kind of has similar problems. It needs hardware accelerators for the biggest stuff. That's something Kube doesn't support well. So even though we wouldn't actually go implement all that support, we can provide requirements. We can say, well, what do all of the people running inference need when they're serving workloads on top of Kubernetes? But we don't want to just end up and walk away from this and say, oh, cool, we made accelerated large language model inference on top of Kubernetes. Awesome, we're done. We'd like to, I think, continue some of the key challenges that when we first did Kubernetes 10 years ago, we put in services and deployments and stateful sets and pod disruption budgets and horizontal pod autoscaling. Those are really great primitives. They're not that powerful, but what they do is they allow a broad range of workloads to work. There's a lot of problems that people in Kubernetes have today that involve lots of dense workloads running together where there aren't great tools to let Kubernetes manage that density for you because Kubernetes doesn't know. And so one of my hopes with working group serving is we've got to focus. We want to kind of make that work well, but we want to leave behind improvements that make all serving workloads on Kubernetes better. So disruption budget is a great example. It's a really simple construct. You can say, I don't want Kubernetes to allow anyone to go take away one of my pods if it's below this number. That's the simplest possible thing. It's so simple that a lot of stateful workloads use it and have to work around its limitations, which then causes operational impacts because they say, you can't take away any of my pods. And Kubernetes really wasn't designed to communicate why you can't upgrade a node because there's one pod. We had to go build that stuff. I think there's some stuff coming that we can do that says things like, just as one example, this workload has some really strong guarantees. As long as you keep those higher level guarantees, not just remove one of my pods, but for inference, like, everything's about latency. As long as you keep my traffic, my latency distribution for responses at about this, do whatever you want. And that actually, I think, is a real opportunity because if we have that higher level guarantee, it would work for LLMs, but it might work for web applications. And so, if you remove an instance and your latency is outside your target, we just stop taking upgrades. But that also means that somebody can look at that and say, oh, well, all I have to do is go add more instances to let you upgrade. That could be something where platform teams and Kubernetes as a service offerings could add new capabilities that let you do preemptive maintenance. So I'm actually pretty excited about, we want to make a use case work well and leave behind a better foundation for others.
That is something that I've kind of heard commonly across the Kubernetes contributor community is that AI workloads are special in that they have a lot of focus on them and there's a lot of hype around them. And so kind of everyone has to focus on them, but they're really not that special in that they have these components of a workload that are kind of common to other use cases that Kubernetes has been working to solve anyway. So this is really just a great excuse for the project to focus on some areas where maybe it hasn't gotten to focus as much in the past. And it's going to have benefits across the entire system of Kubernetes that can benefit all types of workloads, not just AI ones. But AI is the excuse to do it.
And I think that you always have to have a reason to make a change. Sometimes I can make something work 1% better isn't enough. I think, if you have a really concrete example, I think I love that example that you gave, because a lot of what we benefit from in Kubernetes, and this is another important part, is at the end of the day, it's not just about this one workload. It's about giving people enough of a foundation, a common foundation, that other workloads can exist. So you don't have to come back and ask Kubernetes. So we often try to design things that are as open-ended as possible. And this gets back to that whole too simple story, which is there's a really hard balance to strike between what are the things that somebody who's familiar with the problem would be like, yep, that's the right way to do it. Finding several sets of people who agree just enough. Because if several different sets of people in different use cases agree that this is something that's valuable, it's probably got legs. The challenge then is that that's a new construct and concept that you have to expose to users. And I'm always sensitive to, I still see this 10 years in, there's people out there who the first time they hit Kubernetes is like being hit with a tsunami of concepts. You got to learn pods and services and workloads and the controller pattern and spec and status and watching and nodes and disruption budgets. And so I think there are things that we should think about while we're doing this. How do we balance between adding so much flexibility for accelerators and supporting all this new hardware? What do end users actually want most of the time? They're mostly going to be running these classes of workload. Let's make sure that the support that we add is no more complex than SB. And that's super hard. I don't think we've always succeeded at it. And we'll always bias a little bit more towards flexibility than simplicity, because that's why people use Kubernetes.
Wonderful. Kubernetes is a platform for building platforms.
That's right.
And so to kind of close this up here, is there anything else that you'd like to highlight about the work that Working Group Serving is doing that our audience out there might be able to help you all with, or would be good for folks to know about?
This is a personal appeal. It's often hard, I know, when you're building something and trying to get something done on top of Kubernetes, to take the time to come to working group meetings, to listen in. It takes time out of everyone's lives. The only way that we will be able to make progress on this project called Kubernetes and this effort is when people listening to this say, oh, I'm running inference on Kubernetes. I've actually got some pretty strong opinions about what I need. And sometimes those are lower level opinions. I can't always fix all of them. But what we really need are the use cases. Like, this is important. And that there are people out there who know far more about running inference on Kubernetes than I do. My job, and part of the reason why this podcast is so important, is as a community, if you're out there and you're hoping that somebody's going to make your future life easier, that person exists, that person is me. Come to Working Group Serving. Just give us a use case. Give us 10, 15 minutes of your time. Write a blog post and share it with us. That kind of feedback, what do you want out of inference and accelerated inference and large language models on top of Kubernetes, will help not just folks today, but the next 10 years of people building things on top of Kubernetes. And only you have the power to make sure that we implement the right thing.
If we don't hear your use cases, then it's possible that we could miss something that you could have told us about. And we need to know those examples in order to build the right things.
Absolutely.
So if you want to see the right things built for you, your use case, come on down to Working Group Serving.
Please.
Thank you so much. Yes. Please do. Join the Slack, join the meetings, come say hello. Just send us a little abstract about the use case that you're building. Even that would just really make a difference, I think. All right. So thank you so much for being on today, Clayton. I really enjoyed learning about the early days of Kubernetes and about the future of serving workloads, whatever that may mean, on Kubernetes.
Thank you very much, Kaslin. It was a pleasure to be here.
I am very excited to now be speaking with Don Chen. Don has been a principal software engineer at Google Cloud since May 2007. Don has worked on an open source project called Kubernetes before the project was even founded, really. She's been one of the tech leads in both Kubernetes and GKE and founded Signode from scratch. She also led Anthos platform team for the last 4 years and mainly focuses on the core infrastructure. Prior to Kubernetes, she was one of the tech leads for Google's internal container infrastructure, Borg, for about 7 years. Outside of that work, she is a wife, a mother of a 16-year-old boy, and a wonderful friend. She enjoys reading, cooking, hiking, and traveling. Welcome to the show, Dawn.
Thank you, Kathleen, and thank you for inviting me for this podcast. Yeah, I love to talk to the community and also especially for this special moment, Kubernetes 10th anniversary, and I feel there's so many things to share, and also I want to engage with the community even more through this kind of thing, like larger, even wider community, and through those all kind of the channels, including of the podcast.
I am so excited to be speaking with you. You also got to speak at the Kubernetes birthday bash at the Google Bayview campus in California very recently on Kubernetes birthday on June 6th. And you're one of those folks who has been working on it because you were one of the engineers on Borg. And so you kind of got involved with Kubernetes like in the very early days, like you said in your bio, like even before it was a project, really, because you were already working on Borg. So can you tell me a little bit about what those early days of Kubernetes and kind of working on Borg, what all of that was like?
Yeah, even recently at the birthday, I shared some of the story, right? So I even mentioned that the very earlier load agent, which is kind of like today's the Kubernetes, which is running on every single Kubernetes node. I working on that agent before Kubernetes founded, and that agent actually can support both the pod spec, which back then we call is container manifest, and also can support the Borg API and also Omega API. So it's kind of like we actually at times thinking about we want to open source that agent, but the single agent have the common component, but to support the 3 different type of the API. But of course, that project is being killed by ourselves, even myself, and because it's too complicated. It's just like the beast, and we kill because to fear of the real project, the real open source project Kubernetes, and so. When we found the Kubernetes 10 years ago, and the earlier days, after that, when the earlier days is so excited, and there are intense of the collaborations over across the many companies, immediately got the brass reading of the attention and from the industry. And at that time, back then, our team is really small, but passionate. We have the bunch of folks, 5, I think maybe just 5 of us from Borg team, and 2 or 3 people from the cloud, the Google Cloud. But we are passionate. We share the same vision and to transform how application are deployed and managed. And I remember then after we have like the first talk about that one at the DockerCon, year 2000, announced this, Eric Brewer announced this kind of things. So we are going to do this kind of things. And then we immediately got attraction from Red Hat, OpenShift folks, and IBM, and many other companies, right? So of course, we also got a lot of attention from the Docker back then. So there are many like long hours, like the heated debates, and also have plenty of the pizza. And I'm really mean pizzas because back then there are so many meet up and hang out together. People drop you message and want to meet you. And talk about Kubernetes idea, even like you have no idea where they are. And so that's why I remember that time, that couple, like the summertime, like back then, I ate most of the pizza in my entire life.
Yes.
Drink most of the Coke.
Yep.
I remember most is the shared sense of the purpose. And we really believe what we build in Borg, container technology and container orchestration help Google. And we open source and build this can help more people and can change a lot of the way how and build this standard, right? So the API standard, all those kind of things. So that's what we are thinking. Yeah.
That's so awesome. And I didn't know about the agent piece of it, where you considered open sourcing just like an agent from Borg. I would imagine that would have had a lot of trouble catching on if it was just a single agent rather than this full distributed system like Kubernetes ended up being.
Okay. So that part of actually, I recently shared with the team hacking. I said, E and I just triggered the bootnet to kill our own project. So that is kind of proud, right? So it's really hard to kill your own project, right? You initiate, you start, you put a couple years effort, but then we see the big picture. We see the even better, like the more community friendly, easy collaborate project like Kubernetes and written in the Go language instead of written in C++. It will be have much more value, have the much bigger impact and can leverage community, right? Like it can pick up more talent folks, right, from all over the world. So that's kind of things. So yeah, I feel proud we did it.
That's so awesome. And as you said, you were an engineer on Borg for like 7 years. And the way that you described it, I hadn't really thought about before, honestly, that, Borg is not part of Google Cloud. It's part of Google proper, isn't it? You have the way that Google runs its own data centers and runs its containers across the whole company. So even though Kubernetes, which came from it, is very cloud oriented, Borg itself, of course, is part of the core business of Google and not part of the cloud.
Totally. Even when I first joined Google, that's back to the 2007, and it's almost the same time Google started the series about the cloud business.
Oh.
So when I was joining Google and in the Linux kernel, the C group container technology, it's just a term. It's in some email. Nothing really serious, right? Finalize, right? So like in many cases, I share my first project, like how I'm track process using the back then kernel model and track the process and then figure out what a group of process this belong to one job, which is container, right? So then it goes to the old technology to track the CPU and the memory usage, right? That's the earlier form, how we doing this task management and provide feedback to loop to the Borg. But then at the same time, there's the Google proposed like the C group technology to Linux kernel. So when that time also, because when I first heard that proposal, I said, why don't we do this for cloud?
Yeah.
Why do we do this for cloud? That time literally is the question asked the Palmenergy, who is my tech lead back then. He is the one, together with the Rohit Faz, together proposed the C group technology, memory C group technology. To Linux kernel, totally changed this whole thing. And then he just laughed. He said, oh, haven't happened yet. This is too early. And also he said, oh, there's the security problem. Of course, even today, security problem. It is a pain, right? So that's why we have some other technology, right? So even like Kubernetes support VM-based or hypervisor-based to provide a stronger security. So that's kind of all those kind of things I just want to share. So this is why from day one, it's literally we are thinking about this one. Like I'm like the nobody just join Google. And when I heard this one, then I said, oh, why don't we do this?
Yeah, that's so cool. You started out not only just from the beginning of Kubernetes, not just from the beginning of containers, but from the beginning of C groups.
Yes.
The fundamental technology in the Linux kernel that is behind part of containers. So one thing I want to get straight on this timeline here is you were there when they were starting to come up with the ideas that would later become containers. Where was Borg at when you joined Google? Was it something that had already been kind of established as a project, or was it just starting up as you were joining?
Actually, Borg already started as the project. They already built, but Borg initiated is try to build for Google internal batch workload, right? So back then, Google have the two systems to do this cluster management, job or orchestration. One it is for the batch workload and called work queue. called the worker queue. Another one is for those other production services, latency sensitive workload is called the babysitter. We have the two system parallel. So the cluster actually it is data center also is dedicated like many other company today even. It's dedicated for different team, different PA. And also they divided it into multiple cluster, and those certain cluster may be dedicated for batch workload, certain is for production service, long running services jobs. It's not shared. So when the Borg first built is for batch workload, but batch workload already built something similar, so they didn't immediately see the value from the Borg. Instead, those production services, long-running services job, latency sensitive job, those company, those team like web search, and if I remember correctly, it's web search infrastructure, and they see the value because original babysitter is like the static allocate those, place those job on those dedicated machines, right? So when the machine need to maintain, when the machine need to repair, they need to statically change those configurations. Just like many traditional company before we have the Kubernetes. So they see this value, like the dynamic, place when there's the machine have the problem, how do I have the failure, and also there are even like have the potential, like we see this resource starvation or bin pack issues, so they could move a workload from one machine to another machine, a bad machine to the good machine, and all those kind of things, right? So they deploy of the Borg to using that one, but they don't really have the feedback loop from like what I mentioned that my first job is the tracking process, provide feedback loop, right? So, and the C group is still is like the talking stage, right? So it's kind of like the proposal stage, while the imagination stage.
Yeah.
So they don't have any of those kind of things. So that's why when I first joined, Borg is just only roll out to one or two cluster. But and for those one type of the job, utilization is not the same, performance is not the same, efficiency is not the same. Until 2008, there's kind of this Google internally because economy, all those kind of things, and also like the Google has some because we couldn't get enough of hardware.
Yep. Common problem today too.
Yeah. Yes. So we have like the resource hardware, resource starvation issue. All of a sudden, resource sharing, cluster sharing become to us thing, which is totally change our fortune. And that's the momentum. And Borg fly internally become to standard. So we, at the same time, we quickly build those feedback loop. And so then we can share resource much better. We can guarantee those latency sensitive jobs resource requirement and how often they can access those CPU and memory. But at the same time, we also can need those batch workload to utilize the slack on the machines. So then the utilization from like the kind of like the 10%, 15%, and like the lowest one to shift to like the highest one, 70, 75. So that's kind of how we change around. And so then after that, then we continue, we see this value, quick feedback loop, and then we evolve those Borg, right? So like all those kind of the CPU, memory, disk I/O, and all those kind of things can evolve, booming. The innovation is booming all over the place. Control plane.
Yeah. So many concepts.
Yeah, absolutely. And also on the control plane perspective, and then they also evolve how to accelerate faster scheduling and parallelizing, all those kind of things. And then we enable about hierarchical scheduling for that those like something like you mentioned today, like the topic like HPC workload and like MapReduce workload, all those kind of things. So that's works very well for us.
I had no idea that the early days of Borg were so focused. I mean, it kind of makes sense that they were focused a lot on using the resources efficiently. That's kind of always been part of the concept of distributed systems, right? Making sure that we're distributing our applications and our workloads across the hardware that we have efficiently. But I didn't know that it had a focus on batch workloads, which is really interesting because I was just talking with Clayton Coleman, who was at Red Hat when Kubernetes started up. And in the early days of Kubernetes, they were very focused on stateless workloads and web applications and those types of things. And batch workloads kind of took a back seat for a long time. But Kubernetes always felt like it made a lot of sense with batch workloads because it's this way to connect your applications with the hardware that they're going to use. So it was always kind of there. And I've met a lot of folks in the HPC space and AI space from like before the current era who used Kubernetes because it made a lot of sense for their batch workloads and AI type workloads. So it's very interesting to hear that that is in the roots of it in Borg.
Yes.
So let's dive a little bit into what's going on right now. We've talked about a number of different terms. Let's start with the terminology, as I did in my interview with Clayton as well. We've talked about batch workloads on Borg. We've talked about HPC a little bit. We're going to talk a little bit more about AI today. There's a whole bunch of different terms in play, inference, serving, all sorts of things. So what do you think of the AI terminology right now, and what do you use to describe things?
Just like what you mentioned, we at the earlier time, we are more focused on Kubernetes, more focused on the stateless, right? So there's actually initially from day one, when we start, we actually want to support all the workload. We do.
Of course.
But the Kubernetes, if you really think about it, even today, Kubernetes back then, right? So people just start to realize, thanks to Docker, right? And people start to realize how important the container technology, and especially Docker make this is, I think Docker did an extreme well job to make that technology is accessible to everybody, right? So, and how to figure out how to package those kind of things, and that's fundamentally changed this whole thing. So, but still, Kubernetes come from the first come, and it's really complicated. Even today, it's still complicated, and it's really difficult conceptually and logically, and it's just really hard compared to Docker. Even if you really think about compared to Docker Swarm, right? So people start from like a single node running their workload, then it's actually there's the naturally migration, mind shift from the Docker through the Docker Swarm. But that's not enough. That cannot drive off this large scale problem. So that's why we have to introduce the Kubernetes abstract and the concept from the top. So then we are thinking about, what kind of things we can support. Then one of the things we try to make people thinking about it is, which I disagree from day one, but it turns out that's right thing at back then. So many people try to educate they say, thinking about your pod can be pushed, right? Can be drained. Your container can be drained. Your node is the kernel. Your pod is kernel, not pack. When you think about the statefulness, that's perfect. But because from day one, I'm thinking about support all the workload. I say, no, what are you talking about? Once you have the data, right? So once you have when you support the database, when you support, even you can remote mount it, but you still cannot, because there's the disruptive, right? There's the disruption between, right? When you drain the node, when you do this. So obviously there's the high availability achieved by the duplication. And like replica side give us those kind of things, right? So and all those kind of things, but still you have the disruption, and so that time is perfect. So we start from the stateless, and then later expanded to support the stateful side, and then later we pay attention to the batch workload, right? So you can see that, and then we have so later. We have introduced the high level abstract, right? So job, CronJob, and all those kind of things, right? So, and then we also from day one, long time back, not day one, actually, after we introduce those kind of things at almost the same time, then we also see that needs about the AI machine learning workload. And so you can see like as the signal, I have like luxury to always have the earner engage about the people want to run different type of the workload. So that's why from the node, and then we have to focus on like the how we are enable GPU support, even like TPU support, right? So we build off those device plugin API, enable those kind of things, and then we also need to like the resource like typology a while, right? So make sure on the node side, make sure when this HPC workload or AI machine learning workload land on the node, they can access that resource easily and make sure guarantee of those like special requirement. Then we even expanded that one to make enable about not just know the level of the typology, right? NUMA awareness and even like the cluster level, like typology aware scheduling. So all those kind of things you can think about. We start from a small and very simple, relatively simple stateless workload and expand it to the state for state and for all those CPU memory management to guarantee the resource access, all those kind of things. And also at the same time expand it to batch workload to make sure we have the concept to capture their scheduling requirement, parallelization requirement. And also we expanded to support the special device, right, like GPU, TPU, and also make sure the performance being guaranteed. So that's why I have the CPU management, memory management, and the quality of the services, special those kind of things, and also NUMA association, all those kind of things. Yeah. So
I love the way that you look at this. And I think it's a way that a lot of folks maybe struggle to wrap their head around. A lot of folks will think about use cases from like a higher level perspective of like, here's what I'm trying to achieve, here's what I'm trying to build and things. But from the Kubernetes perspective, someone who's building Kubernetes itself, and especially from someone who has focused on how the nodes themselves are designed in Kubernetes, as you have for so long, the real consideration here is not what you're trying to achieve, it's the requirements that your workload has. And so the words that we use need to be helpful in determining what the requirements are that a system like Kubernetes needs to provide to those workloads. So as someone who works with the node deeply, of course, you think about what different types of hardware are on that node and how you connect the workload with those resources that it uses. And I'm wondering, what kinds of work are you doing today? Are you specifically focusing on AI workloads much? Are you still in the world of the node? What are you doing today?
I always have my question on the data plan, which is include of the node network storage, right? So because fundamentally, there's those user workload will run on the data plan on the node, right? But the node is kind of like my base camp. The reason it is focus on pay extra attention on the node. So I'm not limiting myself on the node only, but to pay extra attention on the node, always making me have the earlier engagement with user, with the vendor, like the device vendor, right? Like the NVIDIA, Intel, AMD, all those things, and also have the earlier engagement with like the Linux kernel folks. So that's kind of the even, and also like the new technology about monitoring, right? So that's kind of the I'm still working on. I'm focused on the data plan, and but additional focus on the node. But I'm not really like recently. I'm looking into how Kubernetes can evolve and to support the multiple host inference job and can evolve to support some of those large distributed applications such as like the framework, like the Ray, Reserve, all those kind of things. I'm looking into those and work with a lot of expertise. I'm not an expert, but I'm just very make sure I listen to them and through some idea, maybe stupid and maybe naive, but just try to motivate those, encourage those conversation, healthy debate, healthy conversation, so then we can evolve Kubernetes. I just like in the past, I think one of the critical difference today compared to before. It is in the past, we kind of support a lot of those workload for Borg. We had some experience, even a lot of evolved performance different. There's a lot of boundary. There's the performance push to the new limit, right? So, but we kind of understand. But just everything's changed so fast. General AI and AI push everything to the new limit, new boundary. We just don't know. We don't understand. And so it's kind of we need to understand. So we need I need to keep telling myself, okay, forget about everything. And it's not really forget. But you have to just compress everything in your mind. Don't treat those kind of things become too for granted because there's new type, everything's new. You need to understand the fundamental what it is, the difference, the new type of workload, what the new challenge it is. Then you can help them to evolve Kubernetes, right? Because I truly believe if we can do good job evolving Kubernetes to support more workload, that's the common interest for the industry, right? So you can always start another orchestration, but that's the cost to start new. The cost to for the even for a company, right? Not Google, right? Outside company, they already spend the time to move to Kubernetes. There's the cost to from the Kubernetes move to other. So evolve Kubernetes is kind of common interest. And also I feel like if being owner to be part of this one, that's kind of things I can continue contribute if we work together to doing things better together. That's kind of what I came from, yeah.
Perfect. And I think that is kind of exemplary of a lot of what the Kubernetes community is feeling right now is the fact that AI is the hype thing is neither here nor there. What's exciting about it for the Kubernetes community and the infrastructure community is that it is a workload that uses so many pieces that have been put in place over the years in these infrastructure systems, and it just pushes them to new heights. And so we're just evolving on the things that we were already working on, really, and using that expertise in infrastructure, in the data plane, in the node, in all of those pieces working together underneath to support this new kind of level of workload in batch and serving and all of these different areas. So it's really just an evolution of the work that you've already been doing for a long time. Wonderful.
It's honored. I'm just lucky involved with Borg and also Kubernetes and now
Yeah.
the AI and all those kind of just feel so lucky.
Yeah, I feel inspired to go read the Borg papers again. So, thank you so much, Don, for being on. I definitely learned a ton from that. And I think we'll wrap it up there. Are there any last things that you want to mention about AI or the history of Kubernetes for our listeners? I think we covered a lot.
But the most, I think the Kubernetes can be today's, like the achieve such of the success is mostly its community and all those kind of collaborative contribution, collaboration. So fundamental problem it is we have, I think this industry, right, have the same set of the problem to manage it, right? So the no matter you are doing the closed source or open source, there's the one side of the problem is common problem, like infrastructure, how to build up the reliable, elastic, and efficient infrastructure. And so the application can run on top of that and worry nothing, right? So we need a share of mind together, work together, and we want more like talented younger generation join this force. And I always feel like the work on the infrastructure is amazing because you are like the, sometimes I feel like we are the kingmaker. A lot of people top of that, they can quickly try, iterate, not worry about the hardware, or not worry about the infrastructure, or not worry about how to use the network. They just, right, so we are kind of like the evolve, like the steady to move forward, but quiet behind. You know, it's not like the people always got most of the attention is those sharing projects running on top of the infrastructure. But infrastructure, people actually supposed should be quiet, hidden. So that's why I keep saying this is kind of amazing for me. But you always have to evolve. You always have there's a new hardware, new device come out, the new technology, new requirement come out. So you have to marching toward. Sometimes you actually have to upfront marching because you have to lead in certain way. So because once you get that, break that boundary, so then the infrastructure end up more technology and the more advanced things. So that's kind of amazing. So I'm really hoping like more people join Kubernetes and work together and evolve Kubernetes together. Yeah.
I think that's a beautiful message to close on. Infrastructure is always going to be there. It's going to be at the core of what we do in computing. And so it's a great place to get involved and learn. So we hope to see more of you in the Kubernetes project as contributors. Hope to see you soon. And thank you so much, Don.
Thank you.
Kathleen, we did it.
We did it.
4 episodes, 1 month. That was a lot of work.
It was quite the adventure. We developed some new systems along this journey for running a series of episodes, like planning them all in advance. And like we had one that was off our usual bi-weekly schedule. And it was kind of an adventure. I don't know if it's quite a month, but very close.
Very close. I mean, just the fact that it was 3 plus 2 plus 3 plus 2. So that's 10 guests in total. Mm-hmm. Or 11, I think.
Yeah. And we still have a long list of folks that we didn't get to talk to. So
yes,
looking forward to the rest of our year's schedule as well.
Yes. We have some really cool stuff coming up. So let's not spoil it up. But I did one episode today. I recorded one episode which is coming today. And there is some other interesting things happening.
And I've got one I'm recording very soon as well. So look forward to that. It's someone that I'm very excited to talk to.
Yes.
But let's talk about Kubernetes. Kubernetes and AI/ML in this case.
Yeah, that was actually super interesting to plan those episodes because Kubernetes have been going through quite a shift in terms of supporting AI and ML workloads, right?
And I think another interesting thing that we got from this is that a lot of the considerations around AI/ML workloads have kind of been there from the beginning in Kubernetes, but a lot of it hasn't been as focused on. We talked a lot in Clayton's interview and in Don's interview about how what I learned from Don is that batch was actually a primary focus of Borg originally. So in the inspiration for Kubernetes, batch was kind of the main focus. And I've learned from talking to folks in the HPC space that it just makes sense, Kubernetes and AI/ML workloads. But the way that Kubernetes has kind of been designed in the world of web applications has been kind of more focused on those types of applications, which have been more common traditionally over Kubernetes lifetime. But now we're seeing this shift, and it feels kind of like actually it's going back to its roots to me.
Yeah, I think Maciej also mentioned that because Maciej mentioned that batch was in the white paper for Borg.
Yep.
That the white paper for Borg actually mentioned the fact that Borg supported both long-running applications and batch type workloads. So it kind of makes sense that made it into Kubernetes because that's the inspiration where Kubernetes came from, right?
Yeah.
But I think that a lot of times people don't realize this. So here is one thing. OpenAI, they have actually a blogs where they write about how they use Kubernetes for training ChatGPT, right? So there is a blog. It's called Scaling.
That's something I need to go read.
Yeah, it's called Scaling Kubernetes to 7,500 nodes. So there is already a blog about that.
7,500. That's all right.
That's nothing. GKE can support 15,000 nodes, right? So
yeah, we hear that a lot
yes.
working for Google.
So, and then there was also a bunch of other, I saw like articles right and left about this. Some of these like super popular AI like frameworks used today, like Ray, for example, has a Kubernetes operator. So yeah, it's taking Kubernetes in a very interesting direction, I guess.
Yeah, so it's kind of this shift that's happening with a foundation, I would say. We've got the fundamental concepts in Kubernetes already, and there's a lot of perfecting that needs to go into it. And also AI/ML workloads these days are, of course, quite different from what they were 10 years ago when Kubernetes was created, or even longer ago when Borg was designing how it handled batch workloads. So there's batch, and there's also the serving components, and LLMs
Yes.
are also quite the different evolution of AI workloads. So there's a lot of details, I think, for the Kubernetes community to dig into, and it seems like they're doing so with enthusiasm.
Yeah. And in my discussion with Maciej, we talked about the job controller and how that job controller got rewritten at some point. I think it was like a complete rewrite to support some corner use cases. So yeah, it was quite interesting. I learned a lot. And then there is this new working groups that we chatted about with Maciej, which I went ahead and added to our backlog of topics to eventually explore at some point.
Yeah.
So you have working group serving, which is inference, and working group devices, which is for accelerators, right, for GPUs and TPUs.
And working group batch, of course, has been around for some time.
Yes.
There's also a couple other working groups that have been spun up recently. So I did really enjoy the focus on working groups in this episode, because I feel like that's something that the general public, you're not going to really know about how Kubernetes itself, like contributing to it and how the project functions, is that we have these working groups where when something comes up, we have a way to spin up a group that's going to focus on it. So I love to see that happening, and I love that we have a chance to talk about it.
Yeah, no, it's pretty interesting. So, no, the episodes were cool. I think Maciej, of course, has a very long experience, have been around for a very long time.
All three of them. This feels like another, like, folks who've been around since the beginning episode. They all have kind of an element of that, don't they?
Yeah. Clayton, I remember particularly that I spent like 2 hours discussing with him at KubeCon Paris this year. We were supposed to sit down for like half an hour, and then the conversation dragged along into like some super deep stuff, and we ended up like talking for 2 hours. I think at some point somebody had to kick us out because they were closing the venue.
And Don being an engineer on Borg before Kubernetes was even thought of.
Of course, yes, yeah.
A very interesting perspective to get there, and I learned some things from that.
Exactly. Yeah, no, it was cool. We did it. We did 4 episodes.
Thanks for sticking with us, folks. If you haven't listened to all 4 of them, would recommend.
Yeah.
I think we covered a good variety of topics. And I think each episode has something a little bit different to offer.
Exactly. And I think we're going to go back to our regular schedule, which is once every 2 weeks.
Better, because we've learned quite a bit about setting up a process around planning our episodes from this.
Exactly.
So.
I like the way we work now, because we can work slightly independently from each other at least for the guests, right?
Yeah.
There's like kind of little dependency on bringing people, finding them, scheduling them, and all that stuff, right?
Yeah.
So yeah, and I had to do all of this while traveling, which is challenging. So now I have to carry this like extra 1.5 kilo microphone with me all the time.
Yeah, I don't know how you do that.
I travel mostly to read, to run, eat, and sometimes there are conferences happening. This is what I tell people. There are 2 key priorities.
and to do podcasts, I guess.
Yeah, but that's just, I happen to be in hotels rooms a lot. So. All right. Thank you very much for listening.
That brings us to the end of another episode. If you enjoyed this show, please help us spread the word and tell a friend. If you have any feedback for us, you can find us on social media at KubernetesPod, or reach us by email at kubernetespodcast@google.com. You can also check out the website at kubernetespodcast.com, where you'll find transcripts, show notes, and links to subscribe. Please consider rating us in your podcast player so we can help more people find and enjoy the show. Thanks for listening, and we'll see you next time.